So back to the chart now. We just calculated the wind correction angles. 2 for this leg, 9 for this leg. These are in degrees. And I didn't explicitly show the last calculation, but it's 15. Hopefully you got the idea how to do it from the first two. So now we can calculate, well, we don't even need much calculation. It's just, reading off the sectional. The magnetic variation, which is essentially just where magnetic north is as opposed to true north, because everything we've done so far has been relative to true north, so we just have to correct for that, because when we're looking at a compass, it's going to be pointing to magnetic north. You can get those correction numbers right off the sectional. You'll see them in big purple dashed lines. I wish I had the software tools to just load that in, but they're just big purple dashed lines, and they'll show the correction you need to make for magnetic north. Around the location that we're doing, it's 14 degrees west, and because this is a very short distance cross-country flight, we can assume it's 14 on all the legs. Again, if it was a longer flight, you'd want to take averages and actually do the calculation somewhere halfway along the leg, but this is a short flight. Just remember the saying, east is least, west is best. 14 degrees west is west, so best meaning positive, least would mean negative, so variation is plus 14, and that's going to be on all of these. And finally, we can calculate the magnetic heading, which is the direction we essentially just have to point our glider in according to the magnetic compass to account for both the wind and magnetic north not being exactly at true north. All you need to do is just add the three numbers you just got. So you'll be adding the true course, wind correction angle, and the variation. Of course, if you get a negative variation, meaning east, you would subtract that. So anyway, we can do that. We get 101 here for that leg, 095, and 086. Okay. And finally, what we need to do is calculate go-ahead points, because we could encounter unexpected sink or something, and we have the minimum altitudes that we need to arrive at our points at, but we also need to calculate at what point do we go ahead with completing the leg or turning back. Go ahead meaning continuing upwind to our destination. So a go-ahead point is usually halfway in between, or halfway along our leg. Right, so this is very simple, just call it a gap go-ahead point. So we need to take the distance of the leg divided in half, and that needs to be multiplied by the altitude you'll consume in in this case, nautical miles, because we're using nautical miles as distances. So that's the first part, and then you have to obviously add the minimum altitude of arrival at the oops, I'm a step ahead of myself there. I'm just writing out the symbolic things here. Yeah, you have to add your landing elevation. I'll call that LE. Alright, so let's do the calculation for this. We have a leg of 5 nautical miles. Divide that in half. Multiply that by the altitude consumed in 1 nautical mile, right? Because that's how much further we'll have to travel. And if we know, well, we calculated before that we will lose 1,086 feet in 1 nautical mile, and we have to travel 2.5 nautical miles. Whatever number this gives us will be how much altitude we need to get to our point at the go-ahead point, which is halfway along the leg. You have to add whatever your landing elevation is, which is 1,066. Okay? If you do the calculation, you will get 37, let me write that below, 3781, 3,781 feet. That's your go-ahead altitude once you reach your go-ahead point, which is halfway along the leg. Okay, we can do this calculation for all these. We'll do these a little quicker though. So our distance is 12, cut that in half, that's 6 nautical miles, times our altitude lost in 1 nautical mile, which is going to be the same, plus 1,006, no, I'm on the previous one. Our new landing elevation is right here, 1,545. And we will get 8,061 feet. Pretty darn high. I'd be a little nervous about making that. And on our last leg, 7 divided by 2 is 3.5. And our landing elevation here is 1,055. And we will get, on our third leg, our go-ahead altitude of 5,346. Alright, so hopefully you enjoyed this overview of how to plan a cross-country. Again, this is the version you would have to do on an FAA check ride. In practice, I'm sure there are many ways to do this, but the point of that was to show you the math involved and how you'd be expected to know it for the check ride. I'm still a beginner myself in this area, and even just planning this, let alone teaching this. So if you guys have any corrections for me or any criticism on how I taught this, I'll most appreciate it. You can just leave me a comment or get in touch with me, and I'll be happy to take a look.